I'm Mrs. Tolmich, and the topic today is scalars and vectors. You will find out that physics is a mathematical science. We are going to be working with math a lot, and in doing so, we need to define quantities like scalars and vectors that have very specific definitions. You might have heard the word vector before if you've watched a popular children's movie. Let me play that now.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh, yeah!
So scalars and vectors are quantities. Scalars have magnitude only, meaning it's just a number. Vectors, on the other hand, have both magnitude and direction, meaning it tells you how big something is and in what direction it's going. So here is a list of a couple of different things we're going to talk about in physics, and I want you to see if you can guess if it's going to be a scalar or a vector. Okay, mass. Is mass a scalar or a vector? Mass tells you how much matter is in an object, and it doesn't have a direction associated, so it would be a scalar. Weight, on the other hand, weight is always acting downward. It is affected by your mass, but mass and weight are two different things. Weight is a vector. You have to have gravity to have weight, and gravity always pulls you down or towards the center of the mass. Now, speed. Speed tells you how fast you're going. So when you look at your speedometer or speedometer in your car, does it tell you what direction you're going, or does it only tell you how fast you're moving? It is a speedometer which only tells you how fast you're going. Now, velocity. A lot of you might think that speed and velocity are the same thing. They are not. They both tell you how fast you're going, but speed tells you how fast you're going. Velocity tells you how fast you're going in a given direction. So 55 miles an hour, speed. 55 miles an hour north, that's velocity. And no, we will not be using miles per hour. We will be using meters per second, but we'll get to that in a minute. Now, acceleration. Does it have a direction associated with it? If you're speeding up or slowing down, it does have a direction associated, so it is going to be a vector, and we'll talk more about this later. What about force? Force is a push or a pull. Can you push or pull in no direction? No. You have to have a direction, okay? Time. Time. There we go. Time. We could say time is always moving forward, but time, you don't say it's 3 o'clock north or it's 3 o'clock east or whatever like that. You just say the time. So that is scalar. Temperature. That is measured on a scale. So it is scalar. We can say the temperature is rising, but that's not really a direction. It's just increasing. Okay. In physics, we're going to have to be very specific about what we say and how we say it. Temperature is a scalar thing. Energy, there's no direction for energy, so that would be scalar. Now, distance and displacement. You know what distance is, how far something is. Well, distance, if I tell you to walk 5 miles, I don't care what direction you're going. I just want you to walk a total of 5 miles. So that is distance. Displacement is very similar to distance. However, it is a vector quantity. So if I'm telling you to walk 5 miles to the store, I need to give you actual directions. There is a place that I want you to go to. So displacement is a vector. You have walked 5 miles north or 5 miles east, something like that. Okay. Don't worry if you don't get it the first time. We will be talking about these all throughout the year, but scalar is magnitude or a number only. Vector has magnitude and direction. Now, vectors are represented by an arrow. The length of the arrow demonstrates the magnitude, and the way the arrow is pointing is showing the direction. So if I want to represent 3 meters per second, I might use this little arrow here. If I wanted to use an arrow to represent 6 meters per second, it would have to be double the length of the 3 meters per second. Okay, so this is 3 meters per second east, and this is 6 meters per second east. The longer the arrow, the bigger the magnitude. Okay, now directions. We will tend to use one of these. We're either going to use north, east, south, or west, or we can say up or down, forward or backward. And the convention is that north, when we're looking at the paper, is always going to be the top of the paper, and east or forward will always be the right of the paper. The positives and negatives can also demonstrate movement, just like in math where you have the different coordinates. If we are moving up, that's going to be positive. If we're moving down, it's negative. Or if we're moving forward to the right or to the east, that is going to be positive, and backward would be negative. Okay, again, we're not going to use all these at the same time, but I want you to just have an introduction to some of the ways that we will denote directions. In the Despicable Me video, Vector is a villain because he is committing crime with both magnitude and direction. Oh yeah.